Communication satellites are anything that's orbiting above the Earth that can bounce a signal that's sent up to the satellite back down to another part of the Earth. Initially, of course, we had satellites that were very close to the Earth. This is called low Earth orbit, or LEO. LEO satellites have a problem, though. The satellite's close to the Earth, so it's moving very quickly to stay in orbit. That means you've got to track the satellite. If you wanted to track a low Earth orbit satellite, you'd have to have an antenna, and when the satellite came over the horizon, this antenna would swing very rapidly across the sky looking the other way, and then you'd have to get the next satellite and swing and do that, and that's a lot of work. If you go out to a distance of about 22,300 miles, then the speed of the satellite matches the speed of the Earth. This is called geostationary, or GEO orbit, and at GEO orbit, the satellite actually appears to remain in a stationary position overhead. So that means you can have a dish that you can point directly to that satellite, and it doesn't have to move, ever, to see the satellite and receive the signal. Whenever you watch a cable channel or any movie channels that you see, your cable company is receiving that signal from a geostationary satellite. Well, the time is probably coming where it would be possible for all of us to have Dick Tracy wrist radios. If you have a network of global satellites in low Earth orbit, then they can talk to each other. You can go up into the network, and the network will build you a circuit and come down wherever you want. So you can stand there with your cellular phone or your Dick Tracy wrist radio and talk to anybody anywhere in the world via satellite. If you want to get into designing, building, launching satellites, you've got to understand the basic math, you've got to understand the basic science. And mathematics and science are about solving problems. And I think the satellite field is going to be very, very exciting in the future.